Hello, and welcome to Backer Breaks It Down. In this episode, we are going to solve logarithmic equations. So there are two ways of solving a logarithmic equation. One of them involves using the definition of logarithm, okay? So we use the definition of logarithm whenever we have like log equals a number, okay? So we're talking that there's a logarithm on one side of the equation. Okay, so the first thing you have to do is you have to get the log alone. So if there's anything happening outside of the log, you need to undo that using inverse operations. Okay, so we want to get the log alone. Once the log is all alone, we're going to use a definition to convert. So what that means is we're going to turn it into its exponential equivalent. Okay, and then we're going to solve for the variable. And then before we declare ourselves completely done, we have to do something where we check for extraneous solutions. And that says m is greater than 0. M is the inside of the logarithm. Because remember, logarithms are defined only for positive real numbers. So the inside of a logarithm has to be a positive number. It has to be greater than 0. So we just need to check and make sure that that is the case. Okay. So the example below illustrates these steps. So here's our equation, log base 2 of x plus 20 equals 3. Get the log alone, well, that's already done, okay? So we're good to go. Step 2, use the definition to convert. So that's what they did here, 2 to the third power equals x plus 20, and then we're ready to solve for the variable. And then the last thing they're doing is they're checking. So notice like they're looking inside the log, plugging in their answer. Negative 12 plus 20 is 8. 8's a positive number, so we are good. Okay, this is a definite solution. Okay, so that's using the definition, and that's like one-sided log equations. Okay, I know what you're thinking. What about two-sided log equations? Well, this is where we use the one-to-one property of logarithms. So basically, you want the equation to be of the form of log equals log. So one log on each side of the equation. And then we can use the one-to-one property to rewrite it, because if I have log base b of m equals log base b of n, then m is equal to n. Yeah, I know, it's like that one-to-one property of exponents. Finally, we can solve for our variable, and then of course, check for extraneous solutions. So here's your equation. You have log base 6 of 2x minus 1 equals log base 6 of 11, right? M equals n, so the insides are equal. So 2x minus 1 equals 11. Solve for the variable x is 6. And then we want to check for extraneous solutions. So basically, we need to look and see, like, if I put the 6 inside, is it positive? Because it needs to be positive. And if I put the 6 inside, I end up getting 11, and 11 is a positive number, so it all checks out. Okay, so you've got two examples in your notes. So feel free right now to pause the video and try out problems 3 and 4, and then check back in with me. We can see how you did, okay? So I'm using either the definition of logarithm or the one-to-one property to solve. Definition of logarithm is where I have like a log on one side and like some number on the other, and the one-to-one property is where I have one log equal to another log, okay? All of this is summarized on your flowcharts. Check it out, right? So step 1 is to get the logarithm alone. And in number 3, my log is not alone. I have this 2 out in front. So I need to first go and divide both sides by 2, because I have to get the log all by itself before I can convert it to its exponential form. So now I have log base 2 of 4x plus 1. I have no idea why that just happened. 4x plus 1 is equal to 5. Okay, so then I can rewrite this exponentially. So remember, the base of the log becomes the base of our power. The log equals the exponent, and then I fill in the rest. So 4x plus 1. 2 to the 5th power, throw that into your calculator. Maybe you just know that it's 32. Okay, and then I'm solving for my variable. So ultimately, I end up with x is equal to 7.75. And then I have to check for extraneous solutions because the inside of my logarithm cannot be negative. And this is all good. Like 4 times 7.75 plus 1 is 32. So I am excellent. And so it all checks out. Okay. In number 4, I have log equals log. And so as you know, when you have log equals log, you can just say the insides of your logarithm are equal to one another. So I can say that 4x plus 9 is equal to 21, and I can solve this equation. So I end up with x is equal to 3, and then I should check for extraneous solutions because the inside of my log must be positive, and 4 times 3 plus 9 is 21, checks out, so it's all good. Okay, so there are 2 ways to solve logarithmic equation. It all depends on what does the equation look like. Okay, and so if you have log equals a number, you're going to use the definition of logarithms to solve that. Okay, so convert it into its exponential and solve from there. And then if you've got logs on each side, log equals log, you're going to use the one-to-one property, and that basically says the insides are equal. The last step always is to check the inside of the logarithm must be positive. And that is how Becker breaks it down.